Hi, I'm Andreas and this is Houdini for Games. Today we're gonna look at the basics of vertex color-driven animation and the way we can use math and gradients to generate lifelike movement. In the example, I'm gonna use a few sine waves to make a grid flop around in a way that could be used for butterflies or a bird, or as in the example, a floppy page from a book. So let's get started. We'll begin by making the grid that we're gonna animate. So drop down a geonode and dive in, and let's add a grid. Like so. It's a bit too big, so we can make this smaller. And we don't need this much geometry at the moment. Because to begin with, we will set this up as the wings of a butterfly, and for that we just need two simple grayscale gradients. And the easiest way to do that is by first flooding the whole grid with a black color. So drop down a color node and set it to black. Then we're going to go into the viewport and we're going to select the endpoints for our gradient where it will be white. So I'm just going to go ahead and grab these 2 points, hit tab and drop down another color node. And that defaults to white, so that's the gradient we want to drive our animation. But we're going to want to do that on both wings, so we're going to move this over to the right a bit. So let's head back to the grid and offset the center a bit. There we go. And now we're going to need to duplicate this plane because we need 2 wings. So drop down a transform node. Now this transform node, we're just going to scale it in -x. Like so. And you can see by the blue tint that it's upside down, so we're going to drop down a reverse node to fix that. There we go. And then we're just going to merge that back together with our unflipped version. So drop down a merge, plug both in, and that's our beautiful butterfly. Before we send this over to Unreal, let's give it a UV map in case you want to texture this later, because, I mean, you're going to want to texture this later. So UV texture node, and you can leave this at default because it's just a grid. It's going to be fine. Then we're going to drop down another transform to scale it up by 100 just to make sure that we're matching the units in Unreal. Otherwise, it's going to be the tiniest little butterfly the world's ever seen. So let's type in 100 and we can check that it works, and it does, but that's just annoying to view. So let's keep the view flag on the UV texture. Now to export it, we're going to drop down on FBX ROP. There we go. Let's specify where we want to keep this and give it a name like basicgrid.fbx. Hit accept. And you can leave all of this at default. So that's going to be fine. Hit save to disk and let's jump over to Unreal. Find a good folder to keep your mesh in and then open Explorer. Find the FBX you just exported. Drag it in. And let's have a look at the import settings. We're not going to need any collision, so let's untick that and open up the mesh settings. Make sure that the vertex color import option is set to replace. Otherwise, you either get rid of them or you get some other funky stuff. But that's all you need, so hit import. Ignore the error because it doesn't matter. And there we go. Let's drag it into the scene and have a look at it. I mean, it might be a bit big for a butterfly. It could be a bird. Or just a really big butterfly. Either way, we're going to have to give this a material, so let's go ahead and create that. And give it a really creative name. And assign it to our mesh by dropping it on there. And it does nothing because the material is empty, so let's open that up and start building our animation. And let's start with the driver of our animation, and that's going to be a sine function of time. This is going to give us a curve that's going between -1 and 1 every second. So let's drop down time and sine. And we want to make it a bit faster, so let's drop down a multiplier as well. Like that, and plug time in. Let's drop down a parameter. So we can control our speed. So let's call it speed. Like so. And we can set the default to 1, so it doesn't change anything by default, but let's just plug that in. And then we can plug this into our sine function. And the sine function goes between -1 and 1, and that's not quite enough. So let's add another multiplier so we can make it a bit bigger of a movement. And let's plug that in and drop down another parameter. And this is going to be our scale. And let's set this default to 100 to account for the units in Unreal. So that's 100 centimeters. Now we have a value that goes between 100 and minus 100 every second. And to use this, we're going to have to translate this to a movement. And we're going to do that by using the world position offset input, because that gives us access to the vertex shader of the mesh, where we can affect the position of the individual vertices. But we're only going to do it in one axis. So let's drop down an append many node. And we're going to plug our function into the up axis, which in Unreal is Z. So plug that in there and take the RGB output and plug that into world position offset. Now we're going to hit apply and have a look at what that does. The preview's looking promising, it's going up and down, but let's have a look at our mesh. It's doing the same. Beautiful. I'm sure this is working perfectly in every way possible, especially if I grab this and start rotating it to see it moving along the same axis. Not quite what we wanted, but it is as expected because we did a movement in local space, but world position offset is in world space. So we need to transform our movement into world space. Transforming between spaces is something that scares a lot of people, but in most engines there's a pre-built transform node, and as long as you know what space you're going from and which space you're going to, it's pretty much plug and play. So let's get a transform vector node, and we're going to set our source to local space and our destination party town or world space. All the different spaces are available in the transform node. So let's just plug this in between our append many and our world position offset. Let's hit apply and have another look. There we go. Now it's moving in the direction of the plane. That's more like what we wanted. So now we can have our butterfly actually rotate and fly about. So the next step would be to make this actually looks like wings flapping. And we can do this by multiplying our sine wave with our vertex color gradient. So where it's white, it will get the full sine wave and the function. And where it's black, it will get none of it. So it will get any movement at all. So let's add in a multiply, grab the sine wave, and let's add our vertex color and plug that in. And then we plug all of this into the scale. There we go. And let's hit apply and see what that does. It doesn't do much on a preview because it doesn't have any good vertex color, but let's have a look at our mesh with our beautiful gradient. And there we go. We got wings moving up and down or something. It is the expected result at least, and it's flapping in the right directions after rotating, so that's all good. But it's not really a wing-like movement. Wings don't just go up and down like that, they rotate inwards, and you can do rotations in shaders, but that's usually quite expensive. So instead what we can do is that every time the wing goes up, it goes into the center, and then it goes out, and when it comes down again, it goes into the center. And that way we can fake a rotation. But to do that, we're going to need two more gradients. One for each wing, because we will need one to move in positive x and the other to move in negative x. So let's jump back to Houdini and set that up. So we're going to need another couple of gradients, and luckily we have more vertex colors to use. I like to use the corresponding color with the axis of movement. So blue would be in Z and so on. Since the different wings are going to need different gradients, let's split the streams up and duplicate the color setup. So copy and paste the color node and plug that into the transform. Okay, so we now still have the exact same setup, just with more control. So let's store the original gradient in the blue channel by simply setting the red and green channels to 0. And let's do that on both color nodes, so we have the same setup on both of them. Now, the new gradients for the x-axis movement needs to start at the same value in the center, so that stays static, but then one needs to go upwards and the other one needs to go downwards. We can't have negative values in our color gradient, so therefore we need to make the center points 0.5, and then the right side needs to go up to 1, and the left side needs to go down to 0. This will give us gradients that go in the opposite directions of each other. And we can easily get it back into negative space by doing some fancy multiplications inside of Unreal later. But now let's start building these gradients. So first, for the right plane, we're going to make it go to 1 at the edge, so we can just use the same color node. On the left plane, we wanted that to go down to 0, so that is already correct. And then we just need to set the center point to 0.5. So let's get a bit more space in here for a selection. Let's grab the center points. Drop in another color node. It's not going to be white. We're going to have this at 0.5 and the other channels are going to be 0 to maintain the gradient in the blue channel. And then we can just copy this node over to the other stream. So we have the same setup on both grids, and that's the correct gradients. So now we have both of our new gradients set up, and it should look like this. And let's get this back into Unreal and see what we can do with it. So just hit Save to Disk on the FBX ROP. There we go. Let's jump over and right-click on the mesh and re-import it to get the new gradients, and watch in despair as our fantastic animation breaks. But that's because we were using all of the channels to multiply with our sine wave. Now we should only use the blue one because that's where that gradient lives. So let's fix that and hit apply and see if we're back to where we were. And luckily it seems we are. So let's start adding the X movement now with the new gradients. So first we need to shove those gradients into our -1 to 1 space, and we can do that with a constant bias scale. So we'll start by setting the bias to -0.5, which will make our gradient start at 0, and then we'll set the scale to 2, which will give us the gradients we're after. So let's start building the actual movement. So let's multiply our constant bias scale with our sine wave, because that will make it move in and out in sync with the up and down movement. And let's also grab the scale multiplier, or its own scale multiplier actually. So let's just copy these two, so we can control how much it should move in and out. And let's call this X scale instead. And then let's plug this into the R channel of the append menu and hit apply and see what that does. And it does something. On the downstroke it looks pretty good, but on the upstroke it does exactly the opposite of what we wanted to do. But that's because of the nature of the sine wave. It goes from -1 to +1, so downwards it's reducing and just shrinking it in, and on the upstroke it's adding, so it's just expanding apart. So what we need to do is that we need to make sure that the sine wave stays on one side of 0. And we can do that by grabbing the absolute value of the function. So let's first make some more space so we can expand our shader a bit. And then let's drop down on abs node and plug that in between the sine wave and the multiply. So what this will do is it will take the sine wave that looks like this and just make sure that it bounces on 0 like this. So if we hit apply and have a look at what that does, and we'll see that it does exactly the opposite of what we wanted. But that's good. We like opposite because that's easy to fix. So let's jump back to the material and just invert this by multiplying it with -1. Like that, and we'll see if that fixes anything. So let's just hit apply. And there we go. We got our flappy butterfly. That's looking a lot more like it. And now we can use all of our parameters to tweak this movement. So we can go in and change the X scale. So maybe it doesn't completely close the wings. Maybe just slightly flaps them inwards. Or maybe it just almost closes them in. Something like that. That looks cool. And now that we can actually see the underside of the wings, let's make sure that the material is two-sided. So let's just tick that and hit apply. Now, if you've been working along with this, hitting apply every time I did, you're probably getting kind of fed up with all of the compiling by now. So in the second part of this tutorial, we're moving back to Houdini to set up a preview system so we can see all of this cool movement without actually having to go into Unreal and export and do all of the recompiling. So let's jump back to Houdini. So the problem with going back and forth between the programs and waiting for compilations and exports is that it reduces the amount of iterations you can go through while trying to figure out what math functions combined with what gradients you want to use to get the movement that you're after. So what we can do is that we can use Vex to simulate what the Vertex shader would do inside of Unreal, as long as you stay within the basic sort of functions. So to do that, let's build a preview node using a point wrangle. We're gonna have to rebuild our material setup using code just to reach parity, but then we can start expanding. So the first thing we did was to set up a time multiplier. So let's just make a new variable called float myTime equals at time times any multiplier. So let's just use 5, or you could replace this with a slider or whatever you want. And close that off with a semicolon. Now, to make it easier to just follow step by step what we did in the material editor, I'm just going to split my view a bit here, like so. Cool. So far we've done this part. We've handled the time. Next, we're going to multiply in our blue vertex color. And it gets a bit confusing here since Houdini uses Y up and not Z up. So we're just going to call it Y move. And then we're going to set that to equals cd.b, just so we have some sort of parity. And after that, we took the sign of our time variable and multiplied it with our Y move. So let's set that up. Y move equals sin of my time times Y move. And that's our movement function. Since we're going to stay in Houdini with this, we don't need to care about multiplying up our scale to match the Unreal units or doing the transform to get it to world space. We can just skip all of that. The next step we need to do is plugging it into world position offset. Like this. Now in Vexland, that simply translates to adding the movement function to the moving axis. So let's do that. At p.y, which is our y position, plus equals our movement function, y move. And that's it. If we go ahead and hit play now, we should see the first step of the animation happening. And it looks like we got our Y movement. So next we need to sort out the X movement as well. So let's have a look at the material and see what we did with that. Okay, then we can start replicating all of this. So first let's read in the red vertex color as a float X move equals cd.r and close that. Then it's the constant bias scale, where we first remove 0.5. So let's do x move minus equals 0.5. And then we multiplied it by 2. So x move times equals 2. Then let's grab the sign of time, just like we did before. So let's set x move equals sin of my time. Like that. And then we push that through an absolute function. So let's wrap this in an abs and close it. And then we inverted this by multiplying it by -1. And finally, we multiplied it with the result of the constant bias scale. So just multiply this whole thing with x move. Then what's left to do is to plug it into the world position offset, which is at p.x plus equals x move, and close that. And if we play now, we're pretty much where we were in Unreal. For the X movement, we did add in a scalar that was a bit smaller than the Y movement. So let's just add that by multiplying this by, let's say, 0.9. Just so it doesn't completely collapse in on itself. There we go. Cool. So now we have parity between the two. So why did we do this? Well, to make it easier to test more movements and prototype things. Let's say I want to add a general up and down motion to the whole mesh. I can simply add more things to the Y component. So let's say at p.y plus equals, and let's say maybe the cosine this time just to get some variation. So cosine of my time, and let's just hit play. And that looks interesting, I like it. It's a bit much though, maybe, so let's just multiply that down by half. And that looks cool. It looks like a bird like flapping itself upwards. So let's keep that and have a look at how to implement this in Unreal once you've figured out your new fancy movement using this preview. So all we did was that we took the cosine of the time, so we can just grab that right here. And then we multiplied that by 0.5. And then we simply added this to the overall up and down offset. So let's drop in add node. And then we're going to add this before we scale this up to Unreal units. There we go. Just add these together and into the multiply. And now we can hit apply and we know what it will look like because we've already tested this. So it's not a big investment to do the compilation right now. And there we go. We got the same movement that we tested in Houdini. Now, while this is already clearly beautiful, Now that we have our preview set up in Houdini, we can use a bit more advanced methods of generating these vertex color gradients to get some more interesting movement. So I want to go ahead and make a bit more of a smoother movement and try to nail that floppy, almost cloth-like behavior. So to do that, we're going to need a bit more geometry. So let's add in a subdivide before our UV texture node. Like so, and maybe 5 steps should be enough. And that should give us plenty to do nice, smooth movements. Right now, though, it will look exactly the same since the gradients haven't actually changed. A good way to get floppy, almost wavy motion is to add a gradient that you offset the time of the animation with. But since that's not a direction, I don't want to use a color for it, so let's store that variable in the alpha. So let's drop down a point wrangle. And I want this time offset gradient to be the distance every point is from the origin, because this will give us a nice radial gradient instead of the linear ones we've used so far. So let's do that by setting at alpha with a capital A equals distance of the position at P, comma 0, which is the origin. And then close that off. And now you can see that we have a gradient that radiates from the middle and gets a higher value as it gets closer to the edges. Now let's add that to our time in the preview. Let's rename the point wrangle first so we know that this is our preview, now that we have more of them. Then all we have to do is add or subtract the alpha from the time. So let's go with minus at alpha. And let's hit play, and we get a completely different result. It's nice and floppy and almost cloth-like, and that's what we were after. But I don't like these sharp edges that we're getting. And they are completely based on the gradient. And therefore, to fix them, all we have to do is tweak the gradient. And we can do that by increasing the contrast of it using a power node. So let's just add pal and set the exponent to maybe 2. Let's see what that gives us. And now you can see it's a lot smoother. It's a more rounded shape. And I really like that a lot. And as you can see, you can use any method to generate these gradients, be it more vex or other nodes, whatever you want to do. And you can get super complex and lifelike movements, even though behind the scenes, it's just a couple of sine and cosine curves. There are a couple of gotchas though. The vertex colors and the alpha all need to fit between 0 and 1 or it's not going to export correctly. So let's have a look and see if our colors do. Well, it does seem that our alpha is above 1. So how can we fix this? Well, we could drop in a fit expression, or we could do a dirty hack and just multiply it down by 0.75, which should bring it into range. Would you look at that? It's all good. And the movement is pretty much the same. So it's just something to be aware of. Keep your values between 0 and 1. So let's get this over to Unreal for a final test. So hit save to disk on your FBX ROP, right click your mesh and re-import. See, it didn't change, but it has the new gradients and it has the new geometry. All we need to do now is tell it to use the alpha to offset the time. So let's just move the time stuff back a bit and add in a subtract. Plug in the time in A and the alpha in B. Connect it back up to our sine and cosine. And that's it. You can clean it up if you want. But let's just hit apply and see what that did. Well, it definitely did something. Don't know what, but I think it looks really cool. Something for you MoGraph guys. But the problem here is that I forgot to compensate for the Unreal units. So let's do that. All we have to do is drop in a multiply, plug that in between the alpha and the subtract, and then multiply it by, say, 0.1. And hit apply. And there we go. We have our floppy bat cloth paper animation done. And it follows where you put it. It works with the rotations, except the normals. The normals don't really get updated as we move in the verts around. And unfortunately, you do have to do that yourself. And there isn't a cut and dry correct way of doing it. It depends on how the verts were moved. There are a few different strategies on how to approach it, like getting the derivative of the displacement function or using screen space derivatives, but that's a too big a topic to cover here. What I usually do in this situation is finishing the effect, check how noticeable the shading or normal problem is, and more often than not, it's actually fine. If it really needs that normal updated, I'll break out the old calculus book and figure it out. There's plenty to read about that online though. Now, the vertex shader for this is done, and you can go ahead and do the rest of the shading with textures and whatnot. The beauty of basing the whole animation on mathimation, if you will, is that no matter how slow you make it or how fast you make it, it's always gonna be smooth, which is a real advantage over other methods like mesh flipbooks or vertex animation textures. And with that, I'm gonna leave you to experiment and find out what you can do with math and gradients. I hope you've learned something from this, and as always, thanks for watching.